Hi and welcome to another video from the Intelligent Auto channel. Today we have a 2011 Ford Transit Connect. It's a 1.8 TDCi and it was recovered in as a crank non-start. So as ever, let's look at some scan data to see if we can figure out why this vehicle won't start. So we're connected to the vehicle now, so have a look at the DTCs. We've got a crankshaft position sensor, circuit A, range or performance. If I try and clear that DTC, it'll clear. So I'm going to now crank the vehicle and see if the DTC reappears. So we'll just go back. And the DTC straight back again. So the engine ECU is obviously seeing an issue with the signal coming from the crankshaft sensor. So first of all, let's identify where the crankshaft sensor is and check to see if it's actually working. What we'll do before we check the sensor is we'll just look at the data PID for engine speed. There's one in here, the engine speed synchronization and revolutions per minute. So let's get them up on screen. I'm going to crank it. And as you can see, no engine speed being registered. So that's the reason why the fault's been triggered. The engine ECU is not detecting engine speed. So here we are at the not so whiteboard again with one of my famously crap drones, just to basically give you an idea of how the crankshaft sensor works on this vehicle. The crank sensor on this vehicle is an inductive type sensor, which means that it actually creates its own voltage. So it looks at the flywheel, and the flywheel has these notches, lumps, bumps, whatever you want to call them, on it, and the crank sensor is looking every time one of those raised sections of the flywheel passes the crank sensor, it creates a voltage on both wires, and that voltage turns into a sine wave, up and down, up and down, up and down. As you can see, there's a gap here. This is where there's a gap in the teeth on the flywheel so that the engine ECU can determine the timing reference for the engine. So each side of this sensor will create a voltage, and the voltage should be equal on each side. But as one side goes negative, the other side goes positive. And what we're looking at is the amplitude of the voltage. So this is 0 through the middle. So we're looking for the same amount of voltage below 0 as we're looking for above 0. Now it does need to see a certain amplitude to be able to register the engine speed, and on an inductive sensor I would say anything above sort of 4 or 5 volts would trigger an engine speed signal. So let's have a look at the sensor on the engine and we'll test this sensor. This is the crank sensor here. As I say, it's looking at the back of the flywheel. I'm actually at the back of the engine block, just between the drive shaft and the engine block. Just to give you some reference. First of all, have a quick look at the wiring, making sure, because obviously it's in a bit of a precarious position, making sure the wiring all looks good, which it does. It's clipped in. So now I'm going to unplug the sensor. I'll look at the connector, make sure it's dry, no corrosion, which is not, and the same in here. And then what I'm going to do is I'm going to put a couple of breakout leads onto this sensor. As I say, it's an inductive type sensor, so it generates its own voltage, so it doesn't need to be plugged in to the engine ECU to be able to test it. So I've got a couple of breakout leads on it, just plugged directly onto the pins on the sensor, and they're connected to my scope wires. So we'll crank this engine and see what signal we're getting from it. As I say, we're connected to the scope, so I'm going to now crank the engine again, and you'll see the signal, or you may not see the signal. We'll see if there's been a signal generated by the sensor. And as we can see, our max voltage is 8.8 volts, and the minimum voltage is minus 8 volts. And then if I look at the minimum there, we've got what, 5 volts. The reason why the scope trace sort of why the amplitude increases and decreases is basically engine speed. It's slowing down, speeding up as it's approaching compression. So this is why you see the signal grow and then decrease. If this had no glow plugs in, or if there was no compression in the engine, we would basically see the same amplitude right across the screen. So what we've done there is we've confirmed that the crank sensor is in fact working. So I'm going to now plug that back in, and I'm going to go back to the ECU and back probe the ECU plug where the crank sensor wires connect, and make sure that the signal exists at the ECU end of the wiring. So there I am. I'm back probed into the 2 wires on the ECU plug that are connected to the crank sensor, and once again I'll put the camera onto the screen and I'll crank the vehicle and see if the signal at this end of the wire corresponds to the signal directly off the sensor. Once again I'll crank the vehicle. And as we can see, the signal strength is equally as good, if not a bit better, than what we had with the sensor unplugged. 9.4 volts, 6.3 volts. So confirming that the wiring is good between the engine ECU and the sensor itself. So next thing I'm going to do is I'm going to depin the plug from the ECU, just to make sure I haven't got a connection issue with the ECU, and do the same test again. I've depinned the 2 crank sensor wires, and I've got breakout pins which are the same size as the ECU pins. I'm just going to put them into there. What this allows us to do is make sure that by using the same size pins, I can verify the grip of the pins, which is good. And then what I'll do is once again connect the scope to the pins, and we'll check to see what the waveform looks like. Here we go again. Again, another good waveform. Nothing there to worry about. Just as a point of interest, the gap I was on about in the not so white board, that's the gap there. That's the missing tooth on the flywheel. So if we take a closer look at this waveform, you can see that's the sine wave there. You see that's the missing tooth on the flywheel. So I think we've got enough evidence there to conclusively condemn the engine ECU on this vehicle. So I hope you found that interesting. Quick and easy way of testing a crank sensor and a crank sensor circuit on a vehicle. Just to give you a bit of background on this vehicle, this is actually the second time I've seen this vehicle. The vehicle was originally recovered into me a couple of weeks ago as a non-start, and it had a crank sensor fault. I started off doing exactly the same tests as I've done today. Went to the crank sensor, checked the plausibility of the crank sensor, it was good. And then when I went to the engine ECU, I realised that the wheel arch liner, which lives in here, was all broken. And there was only a very small amount of it left just behind the wheel here. Now the engine ECU, as you can see there, lives up the back of this wing at about this position here. And as you can see, as you would have seen when I was down there testing it, it's pretty cruddy and crappy. And it was actually worse than that because I've cleaned it up a bit. But when I pulled the multi-plugs off, all the multi-plugs were full of water. So I cleaned the multi-plugs out, dried them out, made sure there was no corrosion on them, which there wasn't, and I actually bought a new wheel arch liner for it, which that's the wheel arch liner I've just taken out. As you can see, it's a newish unit, basically to protect my repair. The van went out, the guy used it for about a week, 10 days, and it broke down again, and it was recovered back into his same crank sensor fault. So all I can assume is that the water is actually getting into the ECU. So this ECU is now going to get replaced with a used unit, which I'll code up to the vehicle, and hopefully that should be the end of it. The wheel arch liner will be refitted again to protect it. So maybe there'll be a second video for this one, maybe not, but there's a new ECU, well, a used ECU on order for it. Thanks for watching. Get down in the comment section with any questions, queries, concerns, in the words of Eric O, on the tests I've just done. If you think I've missed something, I would appreciate it. But as I say, I'm going to go for an engine ECU on this one. Don't forget to hit the subscribe button and hit the bell for notifications for any new content that I'm uploading. Thanks for watching.